Okay, next we're going to look at some comparisons of series. So we're going to do a couple of tests. Our first test is called the direct comparison test. In this, we're going to let a sub n be less than b sub n, but a sub n is greater than 0 for all n. And if the summation of n equals 1 to infinity of b sub n converges, then the summation of n equals 1 to infinity of a sub n is also convergent. So basically what you're going to do is you're given a sub n, and you're going to find a b sub n that converges, and that b sub n is always larger than a sub n. And if you can prove that that larger series converges, then you can conclude by the direct comparison test that the smaller series, the given series, a sub n, also converges. Or you could choose, so this is if you choose a convergent series to compare it to. So if you choose a convergent series to compare it to, it must be larger than the given series. Now, if the summation of n equals 1 to infinity of a sub n diverges, so if you choose a divergent series, that series, then you can conclude that the summation of n equals 1 to infinity of b sub n diverges. So in this case, you're going to again choose a series, but this time you're going to choose a series that diverges, and that's going to be our a sub n. So that's the one you choose. And if that series diverges, the given series, b sub n, will also diverge. So if the small series diverges, then by direct comparison, the larger series must also diverge. Okay, let's do a couple examples. Number 1, determine the convergence or divergence of the summation of n equals 1 to infinity of 1 over 2 plus 3 to the n. So let's compare this to 1 over 3 to the n, because that looks like a good series that's kind of similar to the one given but easier to work with. So we're going to do the summation of n equals 1 to infinity of 1 over 3 to the n. Well, this, if you look at this, I can rewrite this, factor out a 1/3, and rewrite that as 1/3 times 1/3 to the n minus 1 power. So that means this is a geometric series. And this geometric series has an r equal to 1/3. And since that absolute value of 1/3 is 1/3, and 1/3 is less than 1, we know that this geometric series must converge. So the next thing I got to do is, now that I have a convergent series, remember the convergent series must be larger than the given series. So I need to compare the fraction 1 over 3 to the n to the fraction 1 over 2 plus 3 to the n. So I need to compare my a sub n and my b sub n together. And I'm hoping the one I picked is a larger than the one given. So we're going to look at 1 over 2 plus 3 to the n and 1 over 3 to the n. So notice the denominator of the first fraction is larger than the denominator of the second fraction, so that means it's a smaller fraction. So that means 1 over 2 plus 3 to the n is smaller than 1 over 3 to the n, which meets our requirement for a direct comparison test. So I can conclude by the direct comparison test. So since I have a convergent series that is larger than the given series, I can conclude by direct comparison that the series n equals 1 to infinity of 1 over 2 plus 3 to the n converges. Okay, so let's look at example number 2. Now I would try 1 over the square root of n to compare it to. So we'll compare it to the summation of n equals 1 to infinity of 1 over the square root of n. And then that's the same as a p series that has a p is equal to 1/2. And when p is less than or equal to 1, it's a divergent p series. So that means this is divergent. And so I need to compare our fraction to our given, our b sub n and our a sub n together. And I see that 1 over 2 plus the square root of n is smaller than 1 over the square root of n. But I'm comparing it to a divergent series, and the divergent series must be larger than the given series. So that means I cannot do direct comparison with this series. So I cannot choose 1 over n to the 1/2 as my comparison series, because it does not meet the requirements of the direct comparison test. And so the direct comparison test fails to help me if I use that choice. But this doesn't mean that the direct comparison test fails. That just means I need to make a better choice of what to compare it to. So let's try this again, but this time I want to try comparing it to, let's make our series 1 over n. So the summation of n equals 1 to infinity of 1 over n. Now this is also a divergent series. This is the harmonic series, so I know it's divergent. And or you could say a p-series where p equals 1. And so if I compare our two fractions here, notice that we see that 1 over 2 plus the square root of n is larger than 1 over n. Now this is a little hard to see, so let's work out a few terms, because this one you might not see it right off the bat. So on the left, my first term is smaller, but then when I get to my second term, it's larger than my second term on the other one. Then it's larger than my third term is larger than my third term, and it's larger. So that's how I conclude that 1 over 2 plus the square root of 2 is greater than 1 over n. Now, it's not for the first term, but remember, it only cares about what's happening toward the infinity as it gets larger and larger. So that means I can do direct comparison. I have a divergent series that's larger than my given series, so I can conclude that the given series diverges by direct comparison to the series 1 over n. And that's all you do in order to work the direct comparison test.